Okay, so for this, I have an 1,100 kilogram car, so that gives me mass 1, traveling at 17 meters per second. So I have velocity 1, that's 17. To the right, when it collides head-on with a 1,600 kilogram, move my face, I have M2, 1,600 kilograms. 1,600, first one was 1,100. Pickup truck traveling 15 meters to the left. So that's V2. Going to the left, slightly less. Great. So when we think of always upwards and to the right are positive. So the fact that it's moving to the left is a negative velocity, which would make it a negative momentum. So be careful of that. The vehicle is locked together inelastically following the collision. So they crunch and stick together. You have one object here with a mass of, well, both of them put together, M1 plus M2. So we have enough info for the mass and velocity for the car and the truck. That's just P equals MV for each one. Keeping in mind that the truck is moving to the left, so that makes a difference. The combined momentum after the collision. So whatever the total is beforehand, conservation momentum is the total after. And in this case, you have the momentum of the car and the momentum of the truck equals the basically combined momentum of them both together afterwards. So M1 plus M2 times that final velocity, whatever it is. So what direction did the vehicles move after the collision? Well, that depends who has more momentum. So the car or the truck, whoever has more momentum, it's going to end up going in that direction. They win, basically. And how fast were the vehicles moving after the collision? Well, we know the total combined momentum, and for conservation of momentum, that's going to stay the same. So whatever that total momentum is equal to the total mass times that final velocity. We know the total momentum, we know the total mass, solve for final velocity.